Okay, we're on the section about the binomial theorem. So what do? We discussed the what the binomial theorem is for a positive integer value. Certainly we include zero as well, but anyway, we're concerned about expanding these things 1, 2, 3, 4 up to some integer n. We talked about a general pattern to it, and we talked about computing the coefficients of that. All right. It's important you paid attention to that and that you're willing to now see how this is going to apply to problems that you're going to be presented with. So I'm going to switch over to the whiteboard now. Just give me one moment to do so. And I got to get a cable here and start doing the problems on the whiteboard. All right, give me a second. Plug this in. All right, so if you look at problem number 1, it says compute this thing over here. And I'm going to claim this a binomial coefficient. Certainly there's other notations. Some people call this a combinatorial, and it is in fact combinatorial as well, but it's also a binomial coefficient. How do you compute this? I'm going to write down the formula for you. And that's going to be typically n, and then there's r here. This would be n factorial over r factorial, and then n minus r factorial. Well, it's easy to write down, but it may not be easy to compute. This is 16 factorial. Sorry about that. And then on the bottom, what do you get? 14 factorial. And then 16 minus 14, which is 2 factorial. Now, I'd hate to see someone compute 16 factorial and then 14 factorial. What I'm going to plan is there's probably going to be a lot of cancellations here. So let's just take a look. It's going to be 16 times 15 times 14. I'm not going to write them all down. I'll just put down a factorial over there. What's on the bottom? 14 factorial. And 2 factorial is just simply 2 times 1. What's nice about this? 14 factorial cancel off. I don't need to compute that. I know it's a number. I know it's non-zero. I don't need to compute that. The next thing, 2 times 1 is 2, and that goes into 16 8 times. So I'm left with a really simple piece of arithmetic. What am I left with? Well, 16, 14. What am I left off with? 8 times 15, which is 80, and 40, which is 120. All right. Now, this is going to be a coefficient of an expansion. I'll point out what the expansion is. A plus b to the 16th power. And you're going to get a term over here. And you put a dot, 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 where there's going to be some term here with a to the 14th and b to the 2nd power. This coefficient corresponds to that, which is 120. Now, by the way, someone could say there's symmetry here too. There's another one also somewhere along the path where it would be 120 a squared b14. You may be surprised to learn that, but it's the orderings of this thing. There's 120 different ways to write down AA and BB, BB. Well, there's 14 of them, right? I hate to write them all down. 2, 4, 6, 8. Whoa, I'm not going to write them all down. That's just crazy. And I wouldn't want you to write them all down either. But anyway, what they want to compute, just a number. They don't want you to interpret it, but it's 120. All right, let's go to problem number 2. And this is really where the notation combinatorial comes in. It's typically written this way. But I want to point out this N, C, R can also be written as NR. It has same meaning. N factorial, R factorial, N minus R factorial. All right, let's write this down. So 27 C 23 is going to be equal to N factorial, which is 27 factorial, over R factorial, which is 23 factorial, over N minus R is 27 minus 23, which is 4 factorial. Now, granted, it may not be easy to do, but I got to be honest with you, it's not impossible. So what do you get on top? 27 times 26 times 25 times 24 times 23 factorial. What do you get on bottom? 23 factorial times 4 times 3 times 2 times 1. What disappears? 23 factorial. It's a non-zero number. It cancels off. What's 4 times 3 times 2? Well, 4 times 3 is 12. 12 times 2 is 24 times 1 is 24. It cancels this. What are you left off with? A fairly simple computation, which is 27 times 26 times 25. And if you do the arithmetic, whether you do it in a calculator or by hand, you get 17,550. All right. I'm going to come in what this means. There's some binomial that's expanded, 27th power. There'd be some term over here that has a to the 23 in it and a b to the 4 in it. And what would the coefficient be? 17,550. There's also another term somewhere along the path where you get A4, B23, and it would still have the coefficient 17,550. All right. I do want to emphasize you should check it out, multiplication that it produces over here. All right. Let's do the next one, which is going to be number 3. And I just say, if you're reading these things, you might say, I don't even know what I'm reading here. But it says over here, what is the middle term of the expansion? So let me write this down for you. This is a binomial. It's t minus 4 raised to the power 8. So certainly, someone says, what do you mean middle term? How many terms would there be? There would be 9 terms. Let me kind of move it over a little bit. Sorry about that. Nine terms, right? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what's the middle one going to be? Well, 1, 2, 3, 4. It's this term, right? There's 4 terms here, and there's 4 terms here. Now, someone says you can write them all down. I don't want to write any of them down, just that one, right? The middle one. So I'm going to claim over here, I have a good idea what it looks like. And I want to point out, and I'll point it out to you that T8, T7, T6, T5, T4. Let me write that down for you. Remember, the binomial is written as an addition problem, so it's going to be T plus minus 4. Right? Now let me talk about this guy here. None, 1, 2, 3, 4. I'll write that down now. What goes over here? 8, 4. All right. Now someone says, do I need to compute that? It would be nice if you can. All right. And I'll point down what I mean by that. I'm going to do the 8, 4 first. And what's that going to be equal to? 8 times 7 times 6 times 5 times 4 factorial. And on bottom, what do you get? 4 factorial times 4 factorial. Well, 4 factorial is 4 times 3 times 2 times 1. What disappears over here? The 4 factorials. I'm going to do some more reductions. 3 times 2 times 1 is 6. That cancels off. And 4 goes into 8 2 times. It's really not that bad, actually. I'm not saying I can't make a mistake. So what do you get over there? Well, you get 70. I'll write that down now. I certainly could do that. And then what do you get? 2 to the 4th. That's not so bad. Now this minus 4 to the 4th power. Not the easiest thing in the world to do. But I hope you know it's at least a positive number. So I'm going to say, minus 4 to the 4th is really the same thing as 2 to the 8th power. And I think I can do it. 2 times 2 is 4, 8, 16, 32. I'm doing this on my hand. 64, 128, 256. I'll write that down for you. So I'll put 256 down. Now, granted, I realize somebody might complain, I don't want to do the arithmetic. Arithmetic is an important skill set to have. Let me put this down. 256 times 70. We'll check with the answer key too. Don't worry about that. What do you get over here? 7 times 6, right? 42. 35, 39. 14 and 3 17. So what do I get? 17,920 t to the fourth power. All right, can do that by hand. All right, let's go to the next page. And we'll do problem number 4 now. Now, somebody says, you may say it's busy work, but we're trying to teach, that you can do this. And, so part of learning is busy work. You get busy with it. All right. So they use the binomial theorem to expand and simplify the expression. It doesn't look that bad. I'll tell you that one reason it doesn't look bad is the numbers aren't bad. I mean, the numbers in the problem are 1x minus 1y. So the first thing I would do in the problem is just simply write this down as 1x plus minus 1y. I'll put that over there. All right. This could also be written as x plus minus y to the fifth power. Well, I think I can write the expansion down, but the coefficients might be tough for me. And I'll talk about multiple ways of doing it. Actually, I'll talk about one way of doing it. So you can get x5, x4. I'll write these down one at a time. x3, x2, x1, x none. All right, then I'm going to go put the y's. So it's going to be minus y to the fifth power, minus y to the fourth power, minus y cubed, minus y squared, minus y to the first power, minus y to the 0th power. Let's talk about Pascal's triangle now. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There's beautiful symmetry here. 1, 5, 10, 10, 5, 1. And I think I have the row I want. It's this row over here. All right. So it's going to be coefficient 1, coefficient 5, coefficient 10, coefficient 10, coefficient 5, coefficient 1. Let's simplify. What's the first term? X to the fifth power. What's the next term? Minus 5x4y. What's the next term? Plus 10x cubed y squared. What's the next term? Minus 10x squared y cubed. What's the next term? Plus 5xy4. Last but not least, minus y to the fifth power. Look at the key. x5 minus 5x4y, 10x cubed y squared, minus 10x squared y cubed, 5xy4, minus y5. Right? Worked out beautifully. We expect them to work out beautifully. All right, let's take a look at this one over here. Again, they're not asking me to do a lot of work, but they're asking me to do an expansion over here. And I'm kind of looking at it, and it says, find the fifth term in from the left. So I'm going to do that, and certainly this thing has an order to it. And I'm going to say fifth term in. So 1, 2, 3, 4, 5. I'm looking for this term. We'll talk about the first factor. What do you have? You have 3x, and you have a minus 10y. Let's talk about the 3x first. 7, 6, 5, 4, 3. I'll write that down for you. Let's talk about the next guy, which is minus 10y. None, 1, 2, 3, 4. Let me put that down for you. We'll do the computation later. What's the coefficient in front? I don't want to use Pascal's triangle. So I'm going to say binomial coefficient 7. Now someone says, what number do you put in the bottom? It's either 3 or 4. It doesn't make a difference. I'll put the 3 down here. I got to do some computations over here, and I may have to use a calculator to do it. But let's do 7, 3 first, that coefficient. So 7, 3. What's that going to be? 7 times 6 times 5 times 4 factorial You may wonder why I stopped at 4. We'll do it in a second. That's going to be 3 factorial, which is 3 times 2 times 1. And then 7 minus 3 is going to be 4. So 4 factorial. That's why I stopped there. This cancels off. 3 times 2 is 6. That cancels off. Left off with 35. That is not a bad number. Let's go to the next guy. 3 cubed. That's 27. X cubed. Oh, now I got what I got. I got minus 10 to the 4th power. It's a positive number. What do you get? 10,000 y to the 4th power. I got to do some arithmetic over here. I know it annoys some people to do arithmetic, but you really need to learn it. So 35 times 27. And again, it's not a speed contest. You take your time doing it. I'd say hopefully not using a calculator to do this, but there would be nothing wrong with that. I'm going to do 20 times 35, which is 700. And then I'm going to do 7 times 30, which is 210. And 7 times 5, which is 35. That may seem strange to you. Let's see, 4, 9, right? And that's this number over here. And I'm going to multiply by this number now. What's it going to be? 9, 4, 5, followed by 4 zeros. I'm going to put some commas in there and write down this letters now. X cubed, y 4. Same answer. Okay, let's keep going. And I think we're going to do number 6 now. Now, of course, when I look at number 6, I notice a footnote. You may want to read that. But over here, they tell me that this has something to do with a binomial. And certainly, I don't see that. I'm going to write it down for you. And it says that this expansion would equal 81. So let's put the expansion down for you. It might look strange to you, but I'm going to write it down. It's going to be 4, 0, x. Give me 1 second. Let's see. 4 minus 0 is 4. And then you get 5 to the 0. All right, let's keep going. Plus 4, 1, x cubed, 5 to the 1, plus 4, 2, x 2, 5, 2. It's tough. I know it's a lot of writing. 4, 3, x 1, 5 cubed, plus 4, 4. And that's going to be x to the 0, 5 to the 4th power. So I'm trying to recognize, it'll look strange to me. I'm trying to recognize that this is actually an expansion of a binomial. What is the binomial, though? I'm going to write this down for you. It's going to be x plus 5 to the 4th power. And what's it equal to? Well, as I said, it's equal to 81. All right, so it's important you can recognize these things for what they are. Now, someone's going to say, I would rather solve this equation here. It's tough. It's a 4th degree polynomial. I don't want to write that down. I want to write down a binomial. And I'm going to use some rules that you learned in prior courses. And I'm going to put x plus 5. By the way, if you went back to complex numbers, this would have 4 solutions. We're not looking for complex solutions. We're going to do the simple thing. What do you get of your plus or minus the 4th root of 81? All right, big question is, do you know the 4th root of 81? And you should. X plus 5 equals plus or minus 3. 3 to the 4th power is 81. So x equals minus 5 plus or minus 3. What does this give you? X equals minus 5 plus 3, which is minus 2. The other answer you get is x equals minus 5 minus 3, which is minus 8. Those answers are listed for you right here. All right, so that's number 6. We just finished that one off. Let's go to number 7. It's the last problem. I think the last problem. So let's take a look. And this one over here, it says, find the term that doesn't contain an x. I have no idea what it is. But I want to tell you one thing. I don't want to write down 13 terms to figure out what it is. So what I'm going to do is I'm going to write it down, and I'm going to try to figure it out. 3x squared over 2. By the way, when I'm doing this, I'm saying I don't know what this guy is. I don't know where he is. Right, 3x squared over 2, and then minus 1 over 3x. And what goes over here? This coefficient thing, 12. And I don't know what goes here. I'm going to call it r. All right. What goes up here? R. And what goes over here? 12 minus r. All right. Let's see if we can do that. And someone says, what do you mean, can you do that? Well, the thing I want to happen is I want the x's to cancel off. This is making the assumption that x is not 0. Well, this problem wouldn't make any sense if x were 0. So let's write this down. You would get 12r. We don't know what r is yet. And you would get, well, let's write this down. 3 to the r, x to the 2r, 2 to the r. A lot of work. This one's going to be crazy. Minus 1 to the 12 minus r. And on bottom, you get 3 to the 12 minus r. And you would get x to the 12 minus r. Well, the only way this could cancel off is if x to the 2r and x to the 12 minus r had the same exact exponent. So what does that mean? 2r has to equal 12 minus r. And I think I can do that. And what would r be? Add r to both sides. You get 3r is 12, and r would have to be 4. So I think I'm ready to write this down now. And I'm not saying it's going to be work for you. It might be. So I'll write this down. So what are you going to get? You're going to get 12, 4. Let's write down all the details. 3x squared over 2. Again, r is 4. And then you get minus 1 over 3x. And 12 minus r, if r is 4, would be 8. I know it's nightmarish. Let's see if we can finish it off, though. And I'm going to put this down for you. It's going to be a lot of work, but not so much you can't do it. 12 times 11 times 10, right? 10, 11, 12, 9, and then I'll put down 8 factorial. What goes on bottom? 4 factorial, which is 4 times 3 times 2 times 1, and then 12 minus 4 is 8 factorial. Well, this is nice. This canceled off. So we just finished this part over here. All right. Now, someone said you didn't finish it. You're right. I got some of it done. Let's put the next thing down. Times 3 to the 4th power over 2 to the 4th power times x to the 8th power. Let's do the next guy. Well, minus 1 to the 8th is going to be 1. 3 to the 8th, and then you get x to the 8th. Well, this is good news. I'll tell you why. X has disappeared. All right. I'm going to keep looking at it. And someone says, why do you look at it? I want to do it. I want to simplify this thing. I want to know what that number is. So I'm going to look at it. I'm going to say 4 times 3 is 12. That canceled. Let's see. 2 goes into 10 5 times. That's nice. All right. 3 to the 4th goes into 3 to the 8th. 3 to the 4th time. All right. I'm seeing 9 is actually 3 squared. That would cancel this guy over here to make it 3 squared. Yeah, it's work. I think I'm good to go. And I'll write it down for you. What do I see on top? 11 times 5. I see nothing else on top except 1s. What do you see on bottom? 2 to the 4th. Let's just go through that. 2 times 2 is 4, 8, 16. Times 3 squared, which is 9. What's 11 times 5? Pretty simple. It's 55. What's 16 times 9? 90 plus 54, which is 144. We're done. Thank you.